All right, everyone, let's go ahead and begin. So today's topic is SwiftUI apps using MVVM Design Pattern. All right, hold on a second. There we go. All right. My name is Mohammad Azam. Okay, let's go. Yep, there we go. I'm the lead instructor at DigitalCrafts. It's a boot camp. So I teach full stack web development, React, Redux, Node, PostgreSQL, and all the other stuff, all the other cool stuff. I'm also instructor on Udemy and LinkedIn. So sometime I travel to California to record some videos for LinkedIn. And I have a lot of courses on Udemy. All right. Author, speaker, explorer, always trying to go to different places and visit different places. All right. So the agenda for this talk is understanding the MVVM design pattern. Now, this is more of a very introductory kind of a talk where I will explain to you that how you can use MVVM design pattern in your SwiftUI applications. We're also going to look at different kind of view model patterns because there's not only like one kind of a pattern that you can apply when you're working with SwiftUI applications. There are a lot of different patterns. And we are going to also look at a demo where I will show you a very, very, very simple app that is built using MVVM design pattern. All right, and we're going to build the app, parts of it, when we are working on the app. Okay. So what exactly is MVVM design pattern? Now, MVVM design pattern, believe it or not, is just a fancy name. That's not the original name of the pattern. The original name of the pattern is actually presentation model. And here's the diagram from Martin Fowler. And you can see it's a pretty old pattern. It goes back to 2004. So where does this MVVM stuff comes from, right? MVVM is just a fancy name given by Microsoft when they started working on the WPF, which is Windows Presentation Foundation. It's a framework for building your Windows application. So that's the part that they said, okay, we're just going to call presentation model the MVVM design pattern or MVVM pattern, model, view model. So MVVM design pattern, it's a design pattern. So just because it's from Microsoft or it's a fancy word from Microsoft, it doesn't really mean that I can't really use it in iOS development or Java development or Android development. It's a design pattern. It doesn't really care about the language that you are working with. You can simply use any pattern that you like. It comprises of three different parts: model, view, and view model. Now, let's take a look at these different layers, that what each of these layers actually mean. The view is something that is seen on the screen with your eyes. All right. So in this particular screenshot, you can see the view is just the movies, right? So you can actually see the list of movies. Let me actually go ahead and also pull up so that I can look at your questions in a different window. All right. So view is simply a list of movies. In this case, that's the view. Now, if you were running this on a TV app, then a view will be, well, whatever is displayed on Apple TV or Apple Watch or iPad. So that will be the view. The view model, and I think that's where the confusion lies a little bit, that what exactly is the point of a view model. The whole point of the view model is to provide the data and the behavior to the view so that the view can work with the data. So either the view can display the data or view can interact with the data. And the data provided to the view model is by the domain layer. And that's the most important part, that the domain layer is the one that is providing you with the data. Domain layer is where all the logic of the application is. This is where your business rules are. This is one of the most important layers of your application. So the domain layer provides the data to the view model, and view model can actually kind of decide that, hey, domain layer, you have like these 30 properties. I don't really want those 30 properties. I only want 5 properties to display. So I'm just going to display those 5 properties on the view. The domain layer gets the data from the database layer, and obviously database layer gets the data from the database. All right. So this is kind of like the hierarchy or the flow when you are developing your MVVM architecture, MVVM application. Now, this actually kind of changes a bit when you are looking at the MVVM design pattern with a client-server applications. The view and the view model kind of remains the same, but there's another piece added, which is called the model, not the domain layer, but a model, also known as the DTO, which stands for the data transfer object. And you'll see that when we're doing iOS development, sometimes we refer to our model or DTO as the domain layer, but it is not. It's not the domain layer. It's simply a data transfer object. If you have written any app that takes data from an API from the server and decodes it into a class or a structure, that particular structure is called the DTO. Because usually it doesn't really have any kind of a behavior, right? I mean, it just has some properties, and the JSON is going to be encoded or decoded to that particular structure. So that is called the client-side model or the DTO, data transfer object. It usually does not contain any behavior, and the only responsibility of the DTO is to take the data from the server, probably in a JSON format, decode it into its own model, and then forward that model or parts of that model to the view model. So in a client-server MVVM architecture, you will see that most of your domain layer will be living inside the actual server. You can see, in this case, the domain layer is right over here, which is on the server side. And that is a very important piece. You should never expose your domain layer, the layer that contains all the business logic and all the functions, to the client side, because anyone can hack it, anyone can call wrong functions, and now you have a very tight coupling with your domain layer. Anything that your business changes, now you have to update your client interface, which is a very, very tight coupling. You should never do those kind of things. All right. Now, once again, domain model on the top. You can see right over here, domain model on the top, how it is different from the view model. The domain model over here for a bank account might contain some properties like the name of the bank account or the name of the person, the account number, the social security number, account ID, date created, and also some behaviors like creating an account, updating account, transferring funds, combining accounts, closing accounts. These are all behaviors that you have which are for the actual logic, actual business rules of the application. So that is called the domain model. The view model, on the other hand, is the one that is simply taking the data and is displaying it on the screen or interacting with the user input, a click of a button. Maybe you scroll something, maybe you hover on something. So those kind of actions are provided by the view model. The view model is only responsible to provide the data that is to be given to the actual view. All right. All right. Now, when we talk about view model, which is responsible for providing the data to the view, we come across many different patterns of view model. One of the model is called, or one of the pattern is called the view model or container view model pattern. First of all, when you are creating view models, you have to be sure that you're creating one view model at least per screen. So if you have a screen like the one that we have right now, which is responsible for showing you a list of movies, as you can see, then I will have one view model which is controlling the entire screen. Now you can see that in this case, the view model that I have is called the movie list view model. I like to prefix my view models with the word view model, so I know that I'm talking about the view model. And everything on the screen will be binded or will be controlled by the view model. So you can see that we have a search function over here, or a search text box. Whenever the person types something in the search box, it automatically gets populated in the search field. Now, one view model, which in this case, you can see the movie list view model, controls the entire screen, but that particular view model can also have other view models. So you can see this particular whole entire screen, this one, is controlled by the movie list view model, but the individual movies, these ones, which are only the Batman movies, these individual movies are controlled by a list of view model. So we are creating another view model, which is called the movie view model, which controls the individual movies. So this is kind of like a parent-child relationship when you are creating a screen view model, also known as a container view model. One view model is controlling the entire screen, and then it is divided into other view models which are controlling other parts of the screen. We can also see this kind of approach, the screen view model or the container view model, in the Stocks application, which is the application in your iPhone. We have the stock news view model, which kind of controls the whole thing, this thing. But then the Stocks application screen is divided into two different sections, right? The top section is displaying the stocks, and the bottom section is displaying the news. So this can be controlled by another view model, which is stocks, but the bottom part can be controlled by another view model, which is news. So you can see that one view model is controlling everything or representing the screen, but that particular view model, the container view model, can contain other view models which are controlling smaller parts of the screen. And by doing this kind of a hierarchy, it always gives you a flexibility that, oh, I needed to add a search bar, or I needed to add something else. Then you can add those things in the stock news view model, which is kind of like the parent of all view models. So that's very interesting that using this container approach in the end gives you a little bit more flexibility. All right. The next one are read-only view models. Those small view models that we have seen that are only displaying information on the screen, which are displaying this movie, they can be represented by code, something like this. And you can call them a read-only view models because, well, there's no way to add some property to it or assign some properties to it. So the prime example is a movie view model. As you can see in the code, it is a read-only view model because it only, well, you can only read it. You can only display it on the view. You can't really assign it. By the way, if you have questions, you can definitely use the chat to ask questions. I will try my best to answer those questions as we go along. The final view model is a view state view model. Now, view state is a term that I am taking from the ASP.NET Web Forms. So if anyone has worked with ASP.NET Web Forms, there was a view state, which basically simply means that you are capturing the values of the input controls and storing it in the page in a hidden field. But obviously, that is not what we do in iOS development. The view state model basically, or view model basically simply says that this view model will be capturing or will be related or responsible for capturing the values. So what this means is that instead of creating multiple fields, one for the multiple state, one for the email, one for the password, and one for the confirmed password, so three different properties in our view model or in our view, we can actually, what we can do is we can simply create a view state view model, which is create account view model, and use that as a state. This means that we can simply bind the properties directly to our view state view model. And now instead of managing 3 different separate fields like email and password and confirm password, we're only managing one particular view model, which is the view state view model, in this case, a create account VM. And that helps you to take input and then simply perform a two-way binding and put that everything inside the create view model. Right. So in this case, I mean, we won't really be using view controllers because this is a talk about SwiftUI. But you can use the design pattern, which is the MVVM design pattern, in your UI kit application, where the default framework or the default design pattern is view controller, or MVC, model view controller. All right. All right, so let's go ahead and take a look at the small demo. So here is our app. You can see this app will have a content view, and we can take a look at the screen and everything. This is a very, very simple app. And what this app is actually doing is it's trying to fetch the sessions from the server and simply trying to display the session. It also have a page where you can create the session, but it doesn't really create the session on the server, all right? The server is the one that contains all the business logic. None of that is implemented. It's just a fake server that I put together. It doesn't really have any logic or anything like that. Now, this particular page or this particular view is not using the MVVM design pattern. So the question is, how can we accommodate, how can we use the MVVM design pattern and add it to our application? So let's go ahead and see what the application actually looks like right now. I mean, right now, it's not really going to display anything, to be honest. I mean, it's literally going to say that there is nothing to display, because as you can see in the SwiftUI code, there is nothing really going on. All right. So what we want to do is we want to display a list of sessions, which is coming from Swift Heroes. So I created a fake server, and that is the fake server we're going to look at that returns you some list of stuff. All right. So you can still see my computer is actually kind of slow, so it is going to take a while for this to load. But you're not going to see anything because we don't really have any sessions. We're not really displaying anything at this point. All right, so the first thing, while it loads, the first thing we want to do is we need to create some sort of a view model to accommodate this particular view. What's the responsibility of this view? Well, the responsibility of this view is to display a list of speaking sessions. All right, now who will be responsible for pulling all the sessions, for downloading all these sessions? You can see right now it doesn't display anything. It's kind of like this. So the person who will be responsible for fetching all the session is the web service. The web service already contains code to fetch or get all the sessions. I mean, these are all sessions fetched from a fake server. I mean, it does return you JSON, but it's all like fake JSON. So now the question is, okay, what do we want to do? Should we just go in the content view in our view and call get all sessions? That's not a good idea. Again, the content view should be asking the view model that, hey, can I get the session? The view model, always remember, the view model is responsible for accommodating the view, providing the data to the view. So this is where I've created a view model. It's called the session list view model. This is a parent model or a container model. This means that this particular view model will be providing the data and providing the behaviors to our content view so that we can display some view models over here. I've also created a model. Now, this is also known as a model. This is not the domain model. This is simply a model. So this means that this particular model Not sure why it's not appearing over here. Okay, so that is not working. All right, so this particular model, which is session, is also known as a DTO. This is the one that will get populated from the server. All right, and then this model is the one that we feed to the view model and then display it on the screen. The reason that we are not directly displaying this on the screen is that this is the DTO. It doesn't really have any behavior. And maybe we need a behavior. Maybe we need to massage the data. Maybe we don't really want to display the title like that, or we want to format the data. And it is not the responsibility of a DTO to do any kind of those things. The only responsibility of the DTO is to get the data from the server, and that's it, and give it to someone else. So session list view model will be responsible for providing the data to the actual view model. Actual view. So how should we implement this? Well, first of all, we need a read-only model. We need a child model that will be displaying every single session. And we don't really have that. So I'm going to go ahead and create another model, which is called the session view model. A session view model is one particular session. So if you're displaying 5 or 30 sessions, a session view model will represent every single session. A session can have a title, and a session can have a speaker. And you can see that over here, I'm formatting the data in a way that the view actually needs. I'm formatting the data, I'm making the title capitalized. But I can do whatever I want over here. If I was displaying some currency, I can format it right over here and give it to the view. So the view can only display it. Using the container view model pattern, we can go ahead and create our session array inside the session list view model. We also want to create an instance of a web service so that the session list view model can go ahead and get all the different sessions. I mean, the session list view model or a view model is not going to perform the fetch on its own. It's going to take help from a web service. Whenever we create an instance of session list view model, we're going to go ahead and initialize it. We're initializing our web service over here. Once we initialize our web service, all we need to do is to call our function, which is get all sessions, and get all the sessions. Now you can see that get all session is not doing the fetch on its own. Get all session is asking the view, asking the web service to give us all the sessions. Now, one of the things that is missing from this view model, the session list view model, is that we assign the value after fetching it, we map through it. You can see that once we fetch all the information from the web service, we get a list of sessions. But those will be the list of model sessions, which is indicated right over here. You can see the result type on line number 24 is not view model. We are returning a session model, the DTO object, or just the client model. We need to go through each of these session models and then map it to our view models. And that is exactly what we're doing over here. On line 27, we go through a list of sessions, a DTO object, and then it returns, it maps it to a session view model, the individual view model that we have that represent individual sessions. Finally, we assign it right over here on line number 27. We assign self.sessions equals to whatever sessions that we are returning, keeping in mind that the sessions property declared on line number 12 inside the session list view model is of type array of session view model. So this view model is for the whole screen, which consists of list of other view models. The question is, even if you do assign this, how are you going to tell the view that there's some new data that I just received and you better update yourself? Go ahead and update and display the session. And that is where the SwiftUI's new features come into play. And one of those features is creating an observable object. Observable object simply means, and it can be only be applied on a class, it means that we can actually observe changes to the properties when you assign them. So since we want to tell our view that, hey, we got the new sessions and you can go ahead and update yourself, you can display those things, we have to mark this with published. This is a property wrapper that is already part of the SwiftUI. And what this says is that every time you set this sessions property, it is going to call an event. It is going to notify whoever is listening. And that person who is listening can go ahead and, well, update their UI, update their user interface, and become in sync with the data. And also, whenever you are assigning the sessions property, you always have to make sure that you are doing it on the main thread. If you don't do it on the main thread, you can get unexpected results. And also, Xcode is actually going to tell you that, hey, you got to do it on the main thread. So with all these changes, now we can go back to our content view, and we can go ahead and display all of this information. So now if I go back to the content view, which is right here, the first thing I can do is I can go ahead and create an instance of the session list view model. So I can go ahead and do that over here. You can see that I'm marking this with observed object, which means that this object is being observed, and now I can get all the changes. I can deal with the changes, I can get the changes, I can display the changes. We also need to make sure that we are calling the get sessions function, and we will call that right over here on appear, which means that the view has now appeared. So we can go ahead and call it over here. So once a view appears, we can actually call this. This is going to call the get all sessions function, which is right here. It's going to take the web service, it's going to go through the web service, and eventually asynchronously it's going to return and assign all those sessions to the sessions property, which is marked with published. And since it is marked with published, it is going to notify whoever is listening, which in this case is the view, and the view can now update itself. Now, we obviously don't really have any way to display it, so we will go ahead and change this to some sort of a control that can be used to display it. All right. Now, one thing to keep in mind is that I'm using a title over here. You should not use a title to determine the change of or uniqueness of a session. So probably you should have some sort of an ID, and most probably a session will have a session ID. I just don't have it. But over here, try to use something a little bit more unique. You should not use a title property to mark the uniqueness of a particular item. All right. Okay, let's go ahead and build this and try to also run it. Now, when the first time you, and the service on which the server is hosted, it usually sleeps. So the first time we are going to make a call, it might take a little bit of time to get it back because it's sleeping. It's going to wake up, and then hopefully it's going to give us the results. So we're just waiting for it to wake up for now. It's a free service, so can't really complain that, oh, why is it taking so long? But it's a free service, so it takes, for the first time, it takes a while. And there we go. So you can see that we were able to fetch all the different sessions, and we were able to display all the sessions in our view. Using the MVVM design pattern, we use a container view model, and we also used a read-only view model whose job is to simply present a session onto the screen. All right. If you have any question, you can definitely go ahead and ask in the Umbrella. I'm actually looking at that, so let me know if you have any questions. All right, so this is how you can use the container view model or the screen view model to display information. Let's take a look at a different part where we are trying to create a new session. So this will be on the page or on the view, which is called the add session view model. All right. Now, if we go to our add session view, which is responsible for creating a session, there are a couple of things that you will note about this. You can see that there is a title on the right-hand side in the preview. You can see there is a title text box and a speaker text box and a save button. And in the add session view, you can see that we are using the form element of SwiftUI. And we are using broken rules. Don't worry about these broken rules. I'll show you later. But focus on this section over here on the top. So what are we trying to do in this small section from line number 20 to 24? Well, we're trying to ask the user to give us a title and also to give us the speaker name using a text box. Whenever we type something in the text box, it goes directly to our two fields, which are at the top, right over here and right over here. So line number 15 and line number 16. And this works perfectly fine. I mean, there's nothing wrong with that. But consider a scenario that you are filling out a long form, maybe to renew your driver license or to even apply for a driver license. I mean, those forms can be really long, right? Or a medical form, that can be insanely long. So if you are trying to do any of those or filling out any of those forms, you will have to create these different properties. A lot of these properties, right? Maybe it's like 10, 15, or even 20 different state properties. So instead of creating individual properties like this, maybe you can take help from the view state view model pattern. And that pattern is very simple because it only says that you will create a particular structure or a particular view model to represent the input fields or the data that you'll be putting in. So if you go and check out the implementation of this particular view model, which is add session view state, you can see it's like really nothing. It's simply a structure that takes in a title and it takes in the speaker. So now we can use this instead of creating these two fields, and we can simply substitute all of this stuff with this part. Now the question is why? Why are we doing all of this stuff? What benefit does it provide? Well, the first benefit it provides is that we don't have to have those 30 fields that were capturing all of these different things. The second benefit it provides is that now this is already filled out, meaning when you type something in the text field, it is already filled out in the add session view state. So this instance will already have all of the information, the title and the speaker and everything, and you can pass this around. And that's exactly what we end up doing. We pass this around. When you press the save button, you can actually pass this around. You can see, let me see if I can actually use this. Here we go. So you can actually pass this around now. So this add session, the whole screen is represented by a completely different view model, which is the add session view model. I mean, I can show you the code for that. It has some rules also built in. Don't worry about the rules. So don't worry about this. Don't worry about that. I just got a little bit carried away and created these rules. But this is the add session view model. And don't worry about these things. And you can see that we have a function called save a session. Yes, that's actually a very good point, that you can also use a view model as a protocol, and so that you can change my test, and you can actually still keep the, okay, so I'll talk about testing a little bit later on, but you can see you can pass in the session view model, and you can then validate it. So it's always a good idea to have managing one instance rather than managing 20 different fields. And by managing one instance, it also gives us a little bit more help so that we can go ahead and validate it. Validation is a different topic, but we're doing a little bit of a validation over here, not too much. All right. So now if we go back to our add session view, you can see that when you click the save button, I simply take the parent or the container view model, which in this case is the add session view model. I call the save session, and I pass in the add session view state, which already has all the information filled out. Once it reaches over there, once it reaches the saved session, we validate it. But now the question is, okay, this is a client-server app. What should we do now? I mean, we have all the stuff in this session view state because when the user typed it out, it already populated automatically by the way of binding. What should we do at this point? Should we just send the view state view model instance back to the server? No. When you are calling the server, you have to make sure that you are using your DTO objects. So that is exactly what I'm doing. I'm converting the session, the person when they typed in, into a DTO object, which is session model. And then eventually we send out that session model over here. This is not going to add anything on the server. It's not really implemented, but this is just to show you that how you can do those things. So how do we convert a view state session or view state view model to a session DTO object or a model object? Well, if you go to your session, you can see that our session has an extension which takes in the add session view state, simply copies the properties and give it back. And that's it. And this is the person, this is actually now, since we are also interested in sending it, it doesn't have to be only decodable, it has to be codable because we are encoding and decoding. So we just updated that, and now it is also codable. So we can send it across the wire, all right? So always make sure that when you are sending something across the wire using a web service, you never send out a view model. You always convert that view model to a particular view, a particular model, also known as a DTO object, a request object, response object, whatever you want to call it. You convert it into that, and then you send the whole thing to the server. Because the expectation of the server might be very different, obviously, than the view model. So if you are sending a view model, and that view model has some behaviors, that's not a good idea, right? So that's why it's always a good idea to change it or to convert it into a DTO object or a model, and then send it with the server. As you can see, I'm doing it right here. And this pattern has been followed. I mean, Microsoft has been doing that for like a billion years. When I was working in 2006, 2007, 2008, and building like WPF application, we use these kind of similar architecture to create request object and response object so that we don't have a very tight kind of like a coupling between the server and the client. All right. So this is all the code that I have. Now in this code, the question is, where is the business logic? Where is your domain layer? So since this is a client-server application, the domain layer exists on the server. Server is the one who is performing all kind of rules and regulations and business logic to make sure that you cannot add multiple sessions, that a person, a user, or a speaker cannot have more than one session that they're speaking, and all of those things. So they are maintained on the server. The client is just a very dumb client. It's simply taking in the information and simply displaying it. Now, if you do want to validate the view model or validate the view, that is again the responsibility of the view model. And you can see that I wrote a very simple validation function over here, which is simply validating the view model state. You can see that how our view state view model is coming in handy because it has all the information. So we can simply go ahead and validate this. There are some projects in SwiftUI that you can simply decorate your properties with the appropriate property wrappers. So you don't even have to do all of this stuff if you don't want to. I think it's called like a validation library for SwiftUI and all that. All right. Okay, so let's move back to the slides. All right, so we've seen the demo. And let's see if I can move forward. Key points. Try to use a container or screen view to encapsulate your child view. So make sure that you are writing one view model per screen. This is always going to give you a little bit more flexibility that in the future, if you like to change something, if you like to add a search bar, if you like to add something at the footer or bottom, the container or the screen view model pattern is going to allow you to do that. And you can apply the same thing to your views also. You can have a much larger screen view, like a screen container view, and all the child containers will be, or the child views will be inside the screen view. And this is a pattern actually follows in Flutter. Flutter is a framework from Google, which uses Dart language, and it is exactly like SwiftUI. I mean, if you know SwiftUI, you can jump onto Flutter. If you know Flutter, you can jump onto SwiftUI. The similarities are actually very much, I mean, they're very, very similar. And in Flutter, what they do is they create one screen view, which can, or the screen or the page, which represent the whole page view. So just like the view model, they also have a container view. Don't write unit tests for your view model. This is where people will be like, whoa, what are you, crazy? What do you mean don't write unit tests for your view model? Well, my question to them is, do you actually have logic in your view model? Do you? I mean, do you have actual logic, a business logic in your view model? If you have, then you got something else coming. Do you write tests for your controllers also? Like your view controllers? You shouldn't be writing tests for your view controllers. What are you putting like logic in your view controllers? That's already wrong. So I've been testing for like 20 years, and what we have seen in testing is that people will just write tests just for the sake of writing tests. You should be testing the business logic layer. You should not be testing your view model. You should not be testing your controllers. Why are you writing business logic in your view model? Why are you writing business logic in your controllers? Now, I'm not saying that the code that you write in your view model never has to be tested. It will be tested, but not with unit tests. You can write your integration test, you can write your acceptance test, and all of those things are going to help you test the actual logic against the real stuff, not some fake stuff that, oh, I can create a protocol and I can inject a protocol and mock it. Why are we mocking stuff? This is the stuff that you own. You don't mock the stuff that you own. You can mock a web service that you don't own. Sure, go ahead and do that. But why are we mocking the stuff that we own? And I'm out of breath now. And the iOS community, and I've seen in general, is that they're like, oh, look, I have like 2,000 tests. Now, that's 2,000 wrong tests. You are testing, I mean, I have seen some of the tests that are checking, can I add something to an array? Oh, I can add 2 items to an array. I can add 5 items to an array. What are we testing? Are we testing Swift language actually? Are you telling me you're actually testing the Swift language? You can add 2 items from an array. Look, I can delete from an array. That's another test. I can delete 2 items from an array. That's 4 tests now. Great. No. So when you're testing, you should be testing the business logic, the brains, the heart of the app. All right? You should not be testing or making up these tests just for the sake of making up the test. So in your application, that's, 2,000 wrong tests, right? And I will also encourage you to test out or to check out behavior-driven development. Now, testing is a very different topic. I don't want to jump into that right now, but behavior-driven development kind of tells you that you have to look at your application or writing the test, not from inside out, but outside in. So you look at the actual feature that you're trying to implement, and you write the test, the failing test, from outside in. So you kind of like start with the acceptance test, and it fails and fails and fails, and then you move to the unit test, and then eventually it actually passes. So make sure that you're writing the right unit test. Writing tests for view model, writing unit tests for view model or controller, or mocking stuff and then putting it in the controller, injecting into a controller or something else, that doesn't make any sense. You should only mock stuff that you just don't own. Why are we mocking stuff that we own? Just call the real stuff, the real thing. And the final thing is that use view state model instead of individual properties. We have already seen that how the view state model can actually help you to encapsulate the whole view text boxes or data. and it can then be passed around. You can you can validate it, you can convert it into a DTO object, and so much more. So try to use those things. It's always a good idea to pass less parameters, less arguments to functions rather than more. So 0 is the ideal number, but 1 is much better than 3, right? So if you're passing 3 arguments to a function, maybe try to see if you can just wrap it around with an object and pass 1. So all of these things actually matter in the long term of your project. Some of the resources, this is one of the books that I wrote in MVVM in SwiftUI, and it is obviously a digital book. It is available on this particular URL. I also have a Udemy course that talks about MVVM design patterns in SwiftUI. Now, this particular course will go a little bit also onto the Node side, meaning JavaScript side, and it will tell you that, okay, how would you write your domain layer? But all of that is written on the server side using JavaScript, Node, and all that stuff. And here's the final course. This course is only about Swift. This is actually the 20-hour course on SwiftUI. It covers pretty much anything that you can imagine in SwiftUI, for like SwiftUI for iOS 14 also. Core data, core ML, and machine learning, and machine learning with SwiftUI or integrating with SwiftUI, MVVM design pattern, APIs, neumorphic design, and just so much more. My contact information, I'm on Twitter, Azam Sharp. My Gmail is azamsharp@gmail.com, and my website is azamsharp.com. And that is pretty much it. Thank you so much for coming to this session. And if you have any questions, we believe that I do have some time for taking questions.